Exercise 12, Event Models, Compounded Events. The good news is that in order to create the correct convoluted or compounded distribution, we do not need to create a one-by-one case for each model of type frequency times impact as we did on the previous exercise. @RISK does have a very powerful function that does the convolution automatically. It is called the RISKCOMPOUND function. It is used to return the sum of a random number of independent random values from a specified distribution. More specifically, it returns the sum of a number of samples from the second distribution, where the number of samples drawn from it is given by the value sampled from the first distribution. Typically, the first distribution is called the frequency distribution, our Poisson, and the second is called the severity distribution. RISKCOMPOUND is evaluated each iteration of a simulation. The first argument's value is calculated using a sample from the frequency distribution. Then this number of samples are drawn from the impact distribution and added together. This sum is the return value for the RISKCOMPOUND function. In other words, use the compound distribution to automatically multiply frequency of annual snowstorms with a Poisson, 6.5 snowstorms per year, times its severity, or impact, with a PERT for a duration of a snowstorm as in exercise 10. Doing this compound function is exactly the same as building previous exercise 11, but it is done automatically. 1. On blank cell B104, click on the Define Distribution icon to select a compound distribution out of the Palette's Special tab. 2. Double-click on the compound distribution to retrieve its respective window. 3. Observe on the Topic Cell Formula section that a compound distribution has two different components, frequency and severity. By clicking on the Risk Poisson segment of the formula, its frequency section, the following chart appears. Also, the parameter section becomes ready to accept lambda, the only required parameter of a Poisson. 4. By clicking on the risk log norm segment of the formula, the severity section, the following chart appears. The parameter section does also ready itself to accept the two required parameters of the severity function, in this case, the suggested log normal. We will not be using the log normal distribution though. The severity will be modeled with a PERT distribution. 5. Click on the Risk Poisson section of the compound function and by clicking on the Assign Excel References as Arguments button, make a reference to cell B72, that contains the average number of snowstorms per year. This is the lambda, or average, required by the Poisson distribution. 6. After clicking on the icon of the upper right-hand corner of this small window, @RISK will take you back to the Poisson with the correct lambda parameter. 7. Now, click on the severity section of the formula, the log normal, and see how @RISK displays now the standard log normal distribution to model severity. We will change this to a PERT. 8. On the function section, scroll down to change from the default log normal to a PERT distribution. 9. By clicking on the Assign Excel References as Arguments button, the following window will appear. 10. Insert referenced values for the minimum, B75, the most likely, B76, and the maximum, B77, the respective used parameters by the PERT. 11. Click on the upper right-hand corner of this small window to return to the updated PERT severity subdistribution of the compound. 12. You can now close the creation of this compound function with its respective subcomponents, for frequency and severity. 13. Declare this cell as an output using the Add Output icon on @RISK's ribbon. It should contain the following function once it has been declared as an output by naming it compound function. Equals risk output, compound function plus risk compound risk Poisson B72, risk PERT B75, B76, B77. 14. Once again, run a simulation with 10,000 iterations. Our intention here is to compare the previously created functions from exercises 10 and 11 with this compound one. If you have already done the two previous exercises, then the results summary window should now contain an overlaid chart. On top of this chart, once the simulation has stopped, we will overlay now the compounded distribution as a third one in order to be able to compare the three simulated outputs. 15. When the simulation finishes, go back to the summary window and drag the previous one with the two outputs overlaid. 16. From the summary window drag the output named compound function of cell B104. The three overlaid charts should look like the following. A minor detail has to be changed on the chart in order to include the information from the third overlaid distribution on the probabilistic bar, since @RISK by default only displays a bar for the first two distributions. 17. Move your cursor on top of the bar, and right-click on it. This will trigger the appearance of a menu. 18. Select delimiter options. 19. On this graph options window to which at risk has taken you to its legend tab, change the number of delimited curves from 2 to 3 and close with OK. You will now be able to observe 3 probability bars for each one of the outputs on the chart. Observe that the second and third overlaid curves are essentially identical. Their numerical difference stems out of natural randomness. In other words, with enough iterations both curves will converge at the same values.